Right, so far the question has asked us to solve this polynomial equation by making the substitution x equals to cos theta and using our binomial expansion of de Moivre's theorem to rewrite this as a trigonometry equation and find the appropriate values of theta and subbing it back into x equals to cos theta. Now that we have our 5 roots of this equation, well, the question turns around and asks us, what are the exact values? So none of this cos business. What are the exact surd values of these two roots? Now this is a good question because it requires us to sort of apply some strategies in solving regular polynomials. Now one strategy we might use, now this is method 1. The best thing to do to start off this question is to probably notice that x equals to cos 0 essentially means x equals to 1. So we know that x equals to 1 is a root. So if we go through with synthetic division, or long division if you prefer, we can find we can factorize the polynomial at least partly by going through long division. So writing it out, 16, 0, minus 20, 0, 5, and minus 1. I'm writing out the coefficients of each of the powers of x of our of our polynomial. And here we write 1 because it's the root. So going through the synthetic division, copy down the 16. 1 times 16 is 16, 0 plus 16 is 16, 1 times 16 is 16, minus 20 plus 16 is minus 4, minus 4 times 1 is minus 4, minus 4, 1 times 1 is 4 is minus 4, 5 minus 4 is 1, 1 times 1 is 1, remainder 0. So what that means is that we factorized our polynomial into the x minus 1, the factor, and these coefficients. So we have 16x to the power of 4 plus 16x cubed minus 4x squared minus 4x plus 1 equals to 0. So it comes down then to try to find the solutions of this polynomial using traditional polynomial methods. Now before we go ahead and do that, it might be good to actually see that cos 2 pi on 5, this angle is 360, as in 2 pi, minus 8 pi on 5. So essentially, these two are equal in value, and so are these two, which is actually going to be very useful as it gives us a hint that perhaps this polynomial can be somewhat factorized simply. Now, the method I don't recommend using all the time because it might not work. It's called factorization by inspection. What I mean by inspection is that, this polynomial looks pretty symmetrical, so we might end up with pretty symmetrical sort of factors coming out of this. And according to the fundamental theorem of algebra, we can factorize this into two quadratic polynomials. So let me try doing that. Write two nice big brackets. Right, so the first thing I like to do is, it's a bit like the cross method you learned in Year 9 and 10. 16x to the power of 4. Well, let's just split that up evenly. So 4x squared, 4x squared. No harm in that. This 1 here, well, let's try putting just 1 here and 1 there. Now, if we do this, we notice that if we multiply these two brackets, 1 times 4x squared and 1 times 4x squared gives us 8x squared, but we want minus 4x squared. So it seems like a long shot to actually get minus 4x squared by putting in a middle term in these two brackets. So why not have them as minus 1? That way we have minus 4x squared, which is minus 8x squared, which leaves us to contribute a positive 4x squared in order to get this term in the middle. And to contribute that 4x squared, we go plus 2x plus 2x. So it seems like these two brackets are actually the same two brackets, which is okay because we know that whatever's the root of this will be the root of that, and we know the roots are repeated in our cosine values up there. So that's the factorization, and if you verify this, which you can pause the video to verify this, it actually works. Obviously, it's not going to work every time we see a polynomial, but hey. One of my students asked me what pills I'm taking to do this factorization. I think it just comes down to a little bit of instinct and practice. Now, if we were to solve this, it's very, very simple. So we say that using the quadratic formula, x equals to minus 2 plus minus bracket 4 plus 4 times 4 is 16 over 8, which gives us minus 2 plus minus 2 root 5 over 8, which is minus 1 plus minus root 5 over 4. Right, so that means we've got these two solutions, which we must match up with cos 2 pi over 5 and cos 4 pi over 5. Now, which one goes with what? That comes down to your understanding of what the cos values exactly mean in a unit circle. So if I was to draw a unit circle here and plot it where 4 pi over 5 and 2 pi over 5 are, you might see that 2 pi over 5 is slightly less than 90 degrees, about here, so that's 2 pi over 5, and 4 pi over 5 is slightly less than 180, so here is 4 pi over 5. Now the difference between these two values is that the cos of these angles are the horizontal coordinates of these 2 points. We have two different values. We have a positive, small number, and a negative, relatively large number. So going through the two options we have minus 1 plus root 5 on 4, which is positive, and we have minus 1 minus root 5 on 4, which is larger and is negative. So I'd say this one will go with the 4 pi over 5, and this one will go with the cos 2 pi over 5, and we have completed the question. Now, if you've put up with my waffling with method 1, and you're not convinced that that's a method, the factorization using inspection is a method that you'd be able to apply in an exam, which I agree with. You know, some exam questions you probably can't just factorize by looking at it. This is method 2, and this actually is the better method because it requires you to know concepts from polynomials very, very well. Now, again, we emphasize that this is essentially 1. This one I'm going to call alpha, which means over here, cos 8 pi on 5 is also alpha because they're the same in value. Over here, call that beta, and so is that. So essentially, after we factorize it, the x minus 1 factor out, we have this polynomial left, and we know it has 4 roots, which come in 2 pairs. Now these are all real roots, so what we can do is think about the product and the sum of these roots. So let's have a look at the sum over here. We have 2 alpha plus 2 beta equals 2. The sum of the roots will be negative the coefficient of the second term over the first, as long as the second term is the power the power downwards. So here we have 16 x cubed. I'm going to have minus 16 over 16, which is minus 1. And over at the product, we have alpha squared, beta squared, which equals to the last coefficient divided by the first. Now, whether it's positive or negative, you count down based on the other powers. So notice how the odd power will give you negative. Even power, you'll take the positive coefficient. So negative, positive, negative, positive. You can also just look at the parity, as in the odd or evenness of the power. So 1 is x to the power of 0, that's even. So you go with that one, which is positive. So we're going to have 1 over 16. Now that's all part of the theory of polynomials. If you're not sure where these come from, check your notes from your textbooks. Now here, a squared plus b squared, which tells us that ab equals to plus minus 1 over 4. But is it plus 1 over 4 or minus 1 over 4? That depends on what we have up there. Notice how both these betas are actually negative values. So we're going to go with minus 1 over 4 since alphas are positive. Again, that comes from the unit circle. Okay, I'll draw it again. Here is 2 pi over 5. here is 4 pi over 5. So that's why cos 2 pi over 5, which is alpha, is positive, and cos 4 pi over 5 is negative. Therefore, we can say that alpha beta equals to minus 1 over 4. Now, before you dive in to actually solve some nasty quadratic equation, given these two pieces of information, and trying to solve them simultaneously, there's a better way. And the way is to just look at what alpha and beta really stand for. If you were to try to solve, what alpha and beta are, what you're really doing is these two are roots of some quadratic equation, which we don't know what they are, but we do know that the sum of roots of the quadratic equation is minus a half, and the product of those roots is minus a quarter. Now that allows us to construct the quadratic equation, without actually knowing what its roots individually are. We just know that, since these two values satisfy these conditions, we can create a quadratic equation from them and figure out the coefficients of that quadratic equation. So let's just make a monic quadratic equation like x squared, and since the sum of the roots is minus a half, we have plus 1 over 2x, the product of the roots, minus a quarter, so we have minus 1 over 4. Now that will be the quadratic equation which has alpha and beta as its roots. And if we went ahead and sort of made it a bit simpler, 4x squared plus 2x minus 1, hey, that looks familiar. That looks like what we had as our factors in method 1 over here. So that means we're doing this right. Now, if you didn't want to do this and went ahead and simultaneously solved them, there's no problem either. So again, we use quadratic formula, and we found that x equals to minus 1 plus minus root 5 over 4. And the same argument applies. We matched cos 2 pi over 5 with the positive smaller value, and cos 4 pi on 5 with the negative slightly larger value. And we have completed the question. So thank you, and post any questions in the comments of this video.